What is artificial intelligence, AI? Artificial intelligence, AI, refers to the field of computer science that focuses on creating machines or software systems capable of performing tasks that typically require human intelligence. These tasks include reasoning, learning, problem-solving, perception, language understanding, and decision-making. AI systems can mimic human cognitive functions and improve over time through learning and adaptation. AI encompasses a wide range of technologies, from simple rule-based systems to more sophisticated algorithms and neural networks that simulate the way the human brain works. Key areas of artificial intelligence AI can be broadly divided into different subfields, each with its own focus and methods. Machine learning, ML. Definition. Machine learning is a subset of AI that enables systems to learn from data and improve performance without being explicitly programmed. How it works. ML algorithms identify patterns in data and use these patterns to make predictions or decisions. There are three main types of machine learning. Supervised learning. The model is trained using labeled data, input-output pairs. The goal is to learn the relationship between inputs and outputs so that the model can predict outputs for new, unseen inputs. Unsupervised learning. The model is provided with data that has no labels, and it must find patterns or groupings, e.g., clustering or association. Reinforcement learning. The model learns through trial and error, receiving rewards or penalties for actions it takes, ultimately learning the optimal strategy or behavior. Applications. Spam filtering, recommendation systems, image recognition, natural language processing, NLP. Deep learning, DL. Deep learning is a subset of machine learning that uses neural networks with many layers, deep neural networks, to analyze large amounts of data. It is inspired by the structure of the human brain. How it works. Deep neural networks consist of layers of artificial neurons, each layer processing data and passing it on to the next layer. These networks can learn very complex patterns from vast amounts of data, making them particularly effective in tasks like image and speech recognition. Applications. Self-driving cars, voice assistants, like Siri and Alexa, medical image analysis, and natural language translation. Natural language processing, NLP. NLP focuses on the interaction between computers and human languages, enabling machines to read, understand, and generate human language. How it works. NLP algorithms analyze and process text data, including tasks like tokenization, splitting text into smaller chunks, part of speech tagging, and named entity recognition. Applications. Chatbots, language translation, sentiment analysis, text summarization. Computer vision. Computer vision enables machines to interpret and make decisions based on visual inputs, such as images and videos. How it works. Computer vision algorithms identify objects, faces, or activities in images, enabling machines to understand the visual world. Applications. Facial recognition, autonomous vehicles, medical imaging, industrial automation. Robotics. Robotics is the design and creation of robots that can perform tasks autonomously or semi-autonomously. How it works. Robotics combines elements of mechanical engineering, electronics, and AI to create robots that can perceive their environment, make decisions, and carry out physical actions. Applications. Manufacturing robots, drones, autonomous vehicles, surgical robots. Expert systems. Expert systems are AI programs designed to emulate the decision-making abilities of human experts in specific fields. How it works. Expert systems rely on a knowledge base of rules and facts, along with an inference engine to make decisions or solve problems. Applications. Medical diagnosis, technical support, financial analysis. Cognitive computing. Cognitive computing is a broad field that aims to simulate human thought processes in a computerized model. It is often used to create systems that can think and learn like humans. How it works. Cognitive computing systems use AI techniques like natural language processing and machine learning to process and analyze data, often with the goal of mimicking human decision-making. Applications. IBM Watson is a notable example of cognitive computing, used in industries like healthcare, education, and business analytics. Types of artificial intelligence AI can be categorized based on its capabilities and how it interacts with the world. Narrow AI. Narrow AI refers to systems that are designed to perform a specific task or set of tasks. These systems are highly specialized and cannot perform tasks outside their defined scope. Examples: virtual assistants, like Siri or Alexa, recommendation algorithms, like those used by Netflix or Amazon, and image recognition systems. Current status. Most AI systems in use today are narrow AI. General AI, strong AI. General AI is a theoretical form of AI that would possess the ability to perform any intellectual task that a human can do. It would exhibit reasoning, problem-solving, understanding, and decision-making across a wide range of activities. Status. General AI does not yet exist and is a long-term goal for researchers in the AI field. Superintelligent AI. Superintelligent AI refers to AI systems that surpass human intelligence in virtually every aspect, including creativity, problem-solving, and emotional intelligence. Status. Superintelligent AI is purely hypothetical at this point and remains a subject of philosophical and ethical debate. Key techniques and algorithms in AI neural networks. Neural networks are computational models inspired by the human brain, consisting of layers of interconnected neurons that process information. Deep learning uses deep neural networks to tackle complex problems. Applications: image classification, speech recognition, and game playing, e.g., AlphaGo. Decision trees. Decision trees are a flowchart-like structure used for decision-making. Each node in the tree represents a decision based on some input data, and the branches represent possible outcomes. Applications: classification problems, such as credit scoring, fraud detection, and medical diagnosis. Support vector machines, SVM. SVM is a supervised learning algorithm used for classification tasks. It aims to find the hyperplane that best separates different classes in the feature space. Applications: image classification, text categorization, bioinformatics. Genetic algorithms. Genetic algorithms are optimization algorithms inspired by the process of natural selection. They use mechanisms like selection, crossover, and mutation to evolve solutions to problems. Applications: optimization problems, such as route planning and game AI. Reinforcement learning, RL. In RL, an agent learns to make decisions by interacting with an environment. It receives rewards or penalties for actions, ultimately learning the optimal strategy. Applications: robotics, gameplaying, e.g., AlphaGo, OpenAI's Dota 2 bot, autonomous systems. Applications of AI healthcare. AI is transforming healthcare by improving diagnostics, personalizing treatment, and automating administrative tasks. Examples include AI-powered diagnostic tools, predictive health analytics, and drug discovery platforms. Finance. In the financial industry, AI is used for algorithmic trading, fraud detection, credit scoring, and customer service chatbots. Transportation. Autonomous vehicles, self-driving cars, are perhaps the most high-profile example, with AI playing a key role in navigation, traffic prediction, and decision-making. Retail and e-commerce. AI helps improve customer experience through recommendation systems, personalized marketing, and dynamic pricing strategies. Entertainment. AI is used in content recommendation, e.g., Netflix, YouTube, gaming, e.g., AI in game design, and creating deepfake technology, manipulating video content. Manufacturing and industry. AI powers predictive maintenance, quality control, and process automation, reducing downtime and improving efficiency. Ethical and social implications of AI bias and fairness. AI models can inherit biases present in the data they are trained on, leading to unfair or discriminatory outcomes. For example, facial recognition systems may be less accurate for people of certain ethnicities. Job displacement. Automation and AI-driven technologies may lead to job displacement, particularly in industries such as manufacturing, customer service, and transportation. However, AI may also create new jobs and opportunities. Privacy concerns. AI systems, especially those that involve personal data, e.g., surveillance, social media analysis, raise concerns about privacy violations and misuse of data. Autonomous weapons. The development of AI-powered autonomous weapons poses ethical and security challenges, as these systems could make life and death decisions without human oversight. And accountability. As AI systems make more autonomous decisions, questions arise about who is responsible if an AI system causes harm or makes a wrong decision. This has implications in fields like law, medicine, and self-driving cars.